In this video, I'd like to show you 4 different problems using the difference quotient. Now, the difference quotient is something that when you take a calculus course, you'll learn what that is. It has to do with the slope of a line, specifically the slope of a tangent line. But the reason it shows up in this course is they want you to know how to use the algebra behind it. We want to be able to simplify the difference quotient. And so when you have the difference quotient, you're always using this formula I have over here to the right, f of x plus h minus f of x over h. And what you're supposed to do is use the specific function that you've been given. So we're going to take a look at f of x equals negative 3x and use that function in this formula. So just to keep things lined up, I'm going to rewrite the formula here. F of x plus h, that's one piece of the puzzle. We'll calculate that. Minus f of x, that's a separate piece, all divided by h. And so when you calculate f of x plus h, you need the function that's given. So remember what that means. It means to substitute x plus h everywhere there's an x. And so our function, you write your function down, negative 3, and the x, remember, goes right there. So instead of putting x, I'm going to plug in what I'm suggested to plug in, x plus h. Minus, well, f of x is defined right here. That is negative 3x. So the minus is in the formula. This is this minus. And then negative 3x is the function. And you don't substitute anything at all for h. Okay, h just stays h. Now once you have this fraction, you simplify as much as you possibly can. So what I'm going to do is distribute this negative 3 inside the parentheses. So it's going to give me negative 3x minus 3h, and then the two negatives here is plus 3x divided by h. Continue to simplify. What you'll notice is the negative 3x and the positive 3x cancel out, and you're left with negative 3h divided by h. Next, if you'll notice, the h's cancel out, which is negative 3 is our final answer. Okay. Now sometimes your answers are still an expression in terms of h, but often your answers simplify to just a whole number. Now here's the things I want you to expect from these problems. When you get to this step on the bottom left, you'll notice that the terms without an h cancel out. Okay, and that happens every time you do one of these problems. That should happen, at least the ones that you're given in this course. So the negative 3x and the positive 3x cancel out, and you're left with negative 3h over h, and then the h's cancel out. So look for, at this step, any term without an any term without an h, so cancel completely, and then your h's will be able to cancel. So let's try another one of these problems. Okay, so once again, I have the formula. I'm just going to rewrite it. F of x plus h minus f of x, and that's all divided by h. So we're given the function 2x minus 4. So I'm going to say 2 times x plus h minus 4. Now that alone is just f of x plus h. Minus, and then our f of x, always put parentheses around your f of x because you're subtracting that and you're going to need to distribute over h. Okay, so let's recap real quick. So highlighted right here, this part is f of x plus h. Okay, this part is f of x. And of course h in the denominator is just simply h. So I see I have the colors lined up for the same pieces. So f of x plus h again means to plug in x plus h everywhere there's an x. So right here we plugged in x plus h. So 2, what used to be x, now it's x plus h minus 4, minus, and then you just, with parentheses, recopy f of x. So I just recopied 2x minus 4, and then in the bottom, divided by h. Now I'm going to do the algebra to distribute. So I'm going to distribute this 2 inside right here. That gives me 2x plus 2h, subtract 4, and then I'm going to distribute the negative 1 inside of here. So this is minus 2x plus 4 divided by h. Okay, now notice what like terms cancel. I have a 2x and a minus 2x that cancel. I have a negative 4 and a plus 4 that cancel. That leaves me with 2h in the numerator. And once again, notice any term without an h as a factor cancels out. And that leaves me with 2h over h. And then the h's cancel to get 2 as a final result. So the third problem, we have the function x squared minus 1. So again, I'm going to copy my formula. So f of x plus h minus f of x, all divided by h. And so for f of x plus h, which is the most challenging part of this formula, I'm going to remove every x in my function and replace it with x plus h. So it may help to write the function down. It is x squared minus 1. I'm going to replace the x, so it's something squared minus 1. And what goes in the something is x plus h. So just this first part is f of x plus h, minus always parentheses around the f of x. So I'm just recopying the function that's given inside the parentheses, x squared minus 1, all divided by h. Now this algebra is a little more involved because we have to expand x plus h squared. And so you may want to go to the side of your paper and FOIL this out. So I'm multiplying x plus h times x plus h. And remember, so first, outer, inner, last. So I'm multiplying the first together. That's x squared. The outers is x times h. So I'm going to put plus xh. The inner terms, h times x is another xh. Remember, the order you multiply does not matter. And then h times h is h squared. Now if I simplify that, I can add these like terms, x squared plus 2xh plus h squared. So when I write that in my problem, already simplified, this first expression is x squared plus 2xh plus h squared. Minus 1, and then distribute the minus sign, minus x squared plus 1, all divided by h. Then x squared and minus x squared cancel out. Negative 1 and plus 1 cancel out. So I have remaining 2xh plus h squared over h. So here's what I want you to notice again, is all the terms without an h end up canceling out. The x squared, the negative x squared, the negative 1, and the positive 1. And so now every term remaining in the numerator has an h. It needs to cancel with this h in the denominator, but I can't do that just yet. The best thing to do is factor out that common h. So if I factor out an h right here, that leaves me with 2x. And I factor out an h right here, that leaves me with plus h over h. So make sure you see that. I factored out this common h, pulled it out front, and that leaves me with 2x plus one of those h's is still there. Now I can cancel this h and this h, and my final result for this difference quotient is 2x plus h. So for the last example, for the difference quotient, we have a polynomial. Notice it's got 3 terms, so this one, the algebra will be a little bit involved. I'm going to rewrite my difference quotient just to remind myself what I'm doing. Don't forget all divided by h. Some people forget that h. Now f of x plus h means plug in an x plus h everywhere there's an x. Well, notice I've got 2 x's in my problem. Okay, I've got an x squared and I've got an x. So that's going to be negative x plus h squared for the first term, plus 2 times x plus h minus 3 minus, in parentheses, negative x squared plus 2x minus 3, all divided by h. So I expand the x plus h. So that gives me x squared plus xh plus xh plus h squared, which is x squared plus 2xh plus h squared. So I have negative x squared plus 2xh plus h squared. And I'm going to distribute the 2 inside here, so plus 2x plus 2h minus 3. And now I'm going to distribute the negative inside that last set of parentheses. So that gives me plus x squared minus 2x plus 3. So we have a long expression all divided by h. Before I can add like terms, I still need to distribute the negative that was originally in front of the x squared, but now in front of the negative x plus h squared. So it gives me negative x squared minus 2xh minus h squared plus 2x plus 2h minus 3 plus x squared minus 2x plus 3, all divided by h. So what we want to do is combine like terms. Now what we expect is every term without an h in it should cancel out. So let's see if that happens. So I have a negative x squared and a positive x squared. So that definitely cancels out. I have a 2x and a minus 2x. That cancels out. And I have a negative 3 and a plus 3. Alright, so that leaves me with negative 2xh minus h squared plus 2h over h. And I factor out a common h. And that leaves me with negative 2x minus h plus 2, all divided by h. So if you notice that, each one of these terms has an h. And I pulled that common h in the front, so if I get rid of this h, that leaves me with negative 2x. If I get rid of one of these h's, I can't get rid of both. If I get rid of one of these h's, that just gives me minus h. And I remove this h here, that's plus 2. Now my h's cancel, and I'm left with the final answer, negative 2x minus h plus 2.